Good morning, everybody. This is week 6 of the Alice Weekly Workshops. Today, we are going to cover control structures in Alice. We'll go over an overview of all the different types of control structures, continue into loops, and we'll see what kind of time we have for what else we can get into today. If you have not joined us before, I will be using the free resources on Alice. Go ahead and start sharing my screen now. So for all of you following along, resources, Alice 3 lessons. We will go ahead and start in on this section here on control structures. We will begin with the control structures overview, see what we can get through into these ones. I might break control structures conditionals into next week. With a lot of these lessons, and I'll call this on as we go, there are smaller lessons that might be helpful for what we're going to cover today that we might not go into, that are just smaller ones to talk about data types or relational expressions, those types of things. There's a section there, and then there's a section down here. And again, I'll reference these as we go. So if you're not 100% on what data types are, you can take a quick peek at this and it'll give you an overview. And then if we get into the relational expressions and it doesn't make as much sense, you can definitely jump into here and get a little bit more as well. So if we go to the lesson, the Google Slides down here, we'll jump into the presentation Google Slides. And this is where we are going to begin. All right, so the biggest one is just what is a control structure? We talked a little bit about this in the very beginning in the introduction to programming in Alice, when we talked about sort of the fundamental types of sequencing and things like that. So really a control structure is just a programming element that tells which statements in a program to execute in what order. So sequential, what we've been doing a lot of till now has been the do in order. Concurrent would be, we had introduced the idea of do together. I don't think we've talked about each and together, but concurrent just means if we are going to process things at the same time. Then we have conditional, and so that is if this thing happens, then we should do something. And then the last one, repetition, which is our count loops. So, just repeat this thing X amount of times for each in. Easier when I have a demonstration to talk about what that one is, and then a while loop. So like while this thing is going on, this other thing should happen. Those are the major sort of top level ways of describing the different control structures that we have in Alice. Where we find these in the Alice code editor is that little strip at the bottom of your code editor. You see the things we talked about, comments before, and the do in order, where we see count, while for each in, if. So here's a little blow up of what's down there. These are going to be what we're talking about today and possibly next week. Code blocks. So when we talk about a code block, whereas the statement was just sort of one line, you dragged it in and that was what it was. These code blocks leave these empty areas, which is where you can then add more functionality. So each type of code block might have a different set of data in the top, and potentially different numbers of open areas where you can add code to it. So the do in order, as we talked about, is just the basic sequential, do this, then this, then this. Just so as we move forward, you start paying attention to this. That do in order is actually called out in the top left corner of my first method and in other places where that is going to be the default behavior. The do together is another very simple block. And so this is the one that was over here. We dragged that in. We talked about anything that you put in there is going to happen at the same time. So in this case, we have something where the clownfish will move forward. At the same time, it will do this custom procedure tail swish, where it would have the back of the tail swing back and forth. So anytime you want multiple things to happen at the same time, it's that do together block. And you can add as many items into here as you want. It's only empty at the very beginning, but will allow you to add more and more content to it. All right, so the each in together is another version of the do together. It is a do together that makes use of an array. So this is another time where if you want to learn more about what an array is, At a more fundamental level, we have a small lesson that is just on arrays and how to set them up and some different places where you can create them. Really, an array in its simplest form is a set of items of the same class type in Alice. So if you see here, there's the bipeds, and on the screen, there's Freya, there's an ice skater, there's the Mad Hatter, and there's a panda. They are all of the type bipeds. So they can all fundamentally, going back to our inheritance one, do the same types of things because they have the same joint structure in there. So an each in together essentially says, I want to do for everything that I've listed in this array, or just, I guess, a simplistic form, this group of items, I want to do the code that is in the code block before it. So in this example, we wanted to create a kick line with these characters. One way to program it would have been to say, I am going to have in a do together block, Freya lift her right leg, Ice Skater lift her right leg, Mad Hatter lift his right leg, Panda lift the right leg. So it would have been, 4 different pieces of code for the right hip turning backwards. Or we can use this for each in block and then essentially add an array of all the items that we want to do that execution of whatever code is in here. And then you drag this little variable down in there. And now all of a sudden, this very simple block right here can have everybody do the kick line at the same time without having to have all those pieces of code. An if-else block. So this is a pretty fundamental one in computer programming. And really it just comes down to I want, if something happens, this thing to happen. And then generally speaking, there's an else statement that says, if that doesn't happen, this other thing should be executed. So that's why it's sort of understood as an if-else statement. We'll get a little bit more into that, but so here's an example of an Alice use case of it where it says, if the camera collides with this treasure chest, I want to collect the treasure. So an example of, I don't want to just collect the treasure at all times. I want it to only happen when a collision with that event happens. Conditional constructions. So this is that if else. You can do that in a loop. You can do it in other places. We're going to go into more depth of each of these types. It will also be important for key presses because really when we're talking about an event where like you enter something into the computer or something like that, we can do a key press, but we want it to be in this example you'll see here, this is for moving the orca around in space, that I want it to be that if it's the up key, I want to do this other thing. If it is the down key, I want to move the orca backwards. And so this is a way that we can do a lot of nested blocks to differentiate. The overview is the if is if a key is pressed, but we want to add more specificity to say that it is dependent on which key we want something else to happen. So this again goes into what we're covering today. The very simplistic versions, you may not need to use variables and events and things like that, but these are things that extend this. And we will revisit what we're talking today when we get into how to do key press events and how to manage variables and things like that. We're going to touch a little bit on those subjects here, but only so that you understand what you need to construct these. This is where, Alice, you can really switch up how you want to learn these things and either address them just as needed to be able to write some code and then readdress them later, or take some of those items as you go. I'm going to elect to go through this one, and then we'll do a little bit of other things and circle back to variables and some other things. All right, so then looping. There is loops that is just the repetition in Alice, in programming in general. In Alice, we have 3 different variations of it. So there is the count loop where you see here where it says count up to 10, which really just says, do this. Have I done it 10 times? No, do it again. 2, 3, 4. When I reach 10, then we stop doing the loop. In this case, it's a jumping jack. So this first set of code would have the playing card, do the jumping jack 10 times. Again, you could do that in code by just copying and pasting playing card 10 times over, but instead you have this very small piece of code. A for each in loop is another variation of, we talked about the each in together loop, which is an extension of the do together, which is just to say, I want to process a version of this for everything that is in the array. A for each in loop says that I want to do it for each of the things that I've put into that array. I want to run this code once. So it's not going to do it all at the same time. It's going to circle back and substitute in. And then a while loop is going to say that it is sort of a Boolean of if it is true. So while this is true is the default. So let's say instead of saying that we want it to do exactly 10 times, we just want to say as long as we are saying that the work count is on, we want the jumping jack to keep doing jumping jacks. We would set a variable that is sort of the work count is active that we could turn on and off and say that while we're working out, he's just going to keep doing jumping jacks. So here's the example in a bigger one, 10 jumping jacks, just keep going. The 4 each in. So let's say we wanted to do the wave where we have a row of characters. So in this case, we have the Yeti, the Troll, Thor, and Rakshasa. So that same way that we set up for the each in together, we created an array of these characters that is bipeds because they're all bipeds. And then we created a procedure that was wave, which is really just both arms going up, rotating up. And so instead of it just saying, if this was animated, and I was showing you the example, it wouldn't be that they all raise their hands at the same time. It would be the first time through this loop, this character's variable gets replaced by the Yeti. So the Yeti would raise his hands. So then it would circle back through again, and it would grab the next one, which would be the Troll, and the Troll would raise its arms. Again, we would loop back, so you see the loop and the arrow going back up, and it says for each one, so next would be for Thor, do the wave, and then for Rakshasa, do the wave. And so when I've reached the end of that list, the loop is completed and the code would keep going. So a great way to create the wave if you're doing something like that. So we have a kick line, we have the wave, we have a couple of options for doing some interesting animations. And then this was the while. And so the while code block is true, work out, continue to do the jumping jack. This is also something that we will use a bunch when we get into sort of events and collisions and things like that, this is sort of an extension of that. Nested code blocks, we talked a little bit about this in the intro programming. This one is very much so, was important then for our do together and do in order to make sure that if we put all of these tail turns in the same do together with this clownfish, they would happen at the same time. So we might only see the net of a left turn. So this is something that we can use over and over again for do togethers. This is also something that you can use for all of these conditions we're talking about. So let's say that we want those jumping jacks to happen while the work count is active. So let's say work count is on, playing card should be doing the jumping jack, but our playing card is a little bit lazy. And so when we're not looking at the playing card cheats and doesn't do jumping jacks. We could add if the camera is facing the playing card, so if the camera is turned to look at it, it will do the jumping jacks, but if I turn the camera away, even if the work count is supposed to be going on, that playing card would actually stop doing the jumping jacks. There's lots of different variations of this. So I guess becoming comfortable with the idea that you will, in lots of cases, be doing multiple levels of nesting, and it is one place where you can get yourself confused. But again, commenting code, looking at it, reviewing it, things like that. So a couple of tips and tricks when it comes to conditionals or control structures. Example is a diagonal move. So a good do together for this one is moving, a rabbit hopping this direction would do a move forward and a move left at the same time, so that we're not having all of our worlds do some very robotic movements of moving up one, over one. We can create these sort of angled movements. We can move on a slope by moving forward one, up one. So here we go, going that. If we want to do clean turns, remember you would probably want to do a move forward and a turn so that while this is happening, it's turning, because if we use just an up and left, it doesn't smooth that, it moves at a diagonal. So something to think about when you're trying to achieve different types of movements with do togethers. Another one where we start doing a bunch of these nesting of different control structures is to remember that the default duration of something in Alice is 1 second. So if you don't have a specified one, each one of these will take 1 second. So in the case where we're having the clownfish move forward to, and we want these 3 other different things to happen where the tail swishes back and forth. If we had left this as the default 1, they would happen at the same time, but this would move for 1 second each one of these take 1 second, so the clown would sort of stop moving forward after this first left tail swish, then the right swish, the left swish. So we add this duration of 3. So you'll start doing a little bit more math when you're trying to align things happening at the same time to make sure that if you're using multiple statements or procedures to match up with another one, that you need to figure out how to make those happen simultaneously and at the same duration. If you decide at a later date that you didn't mean to have this do in order in there, there is the options for, if you right click on any of these control blocks, dissolving or converting. So different control blocks will have different ways that you can modify them after you've added them, or just get rid of them while still maintaining the code that was inside. All right, well, if everybody followed those basics this far, then we are going to do on the control structures overview, there is a brief tutorial and exercise for just testing the very basics of this. So if we go to this one, it is for the basic do together. I'm assuming some people have already played around with this because we covered it earlier, but in case we wanted to, I'm going to use this starter world to download. If you go to the Google Doc, or if you've downloaded this, the basic idea is we're just going to do a very simple one where there is this log. We're going to place the eagle. The eagle will go up and then down. Pretty straightforward, just a way to show the do in order and nesting them together. So in the setting up scenes component of this, it tells you how to build it yourself, or you can download the fly to log setup. That's the one we are going to use. So if I come to Alice, file open, I'm going to browse to my desktop where I have the fly to log setup. Oh, I messed up. I gave you the whole, well, I guess this is the example world that says that is the old, very robotic view of moving. So you move up, over, and down. In the tutorial, what we're going to try to do is, I guess, I have built this part for you by accident and put it in the starter world. Pretend it is not there, or we'll just jump ahead. It'll save us a little bit of time. So you see how that runs and it goes up and over. The next thing we're going to do is we're going to add do togethers to the control structure to make it actually function the way they want. So if we start on 13, again, we've got the do together block down here. So drag the do together block up, and we want to put the move up and forward into the same one. Now, if we run this program, you'll see that moves over slightly, comes back down. So we had that first part pretty smooth down or at an angle. If we come back to this, the next section, predicting what we would do, swap the order of the do together code blocks. So the next thing that we want to add or would want to add is another do together block here, forward and down. And we've sort of achieved what we wanted to do for having it move up and down. So that is sort of doing this part. The next part we're going to do is we have these things in Alice called poses. So you see this here where it's the eagle flying pose. And if you add this into the beginning of the program, and we add it into this do together, you'll see that it opens up the wings, and so it sort of is a default joint orientation for birds. So some of our different classes will have built-in poses that can be useful. We have another one that is called fold wings. If we do that one, if we put it in here in the do together, again, take a moment and think about what you think is going to happen. If we were trying to have it flap as it went up and then flap as it goes down, when we run this one, you'll see that they negate each other. And so if we wanted that to then flap on the way up and then on the way down, we would need to add a do in order inside of this to maintain that this will happen and then this will happen. So we run that world and there's one flap on the way up. I apologize, I may actually be going a little bit out of script on this one, but let's say we wanted to do the same thing and have it flap coming back down. Another tip and trick from a previous lesson was to hold down the Option key to copy and paste. We can add the wing fold down here. Now when we run the world, you see that it actually flaps on both. In this case, it actually works out because we have 1 second for this, 1 second for this, 1 second for this, and 1 second for this. So it all works out in terms of durations. If we wanted to take away this one and have it just open its wings and close its wings on a way down, we can use that dissolve do in order, and it gets rid of this one. So let's dissolve the do in order here. Now when we run this, you see that it doesn't take the full time because this one and these ones are different durations. Unfortunately, our flying pose doesn't have a modified duration. So we would need to adjust these to make them meet our 1 second flying pose. So in this case, we will do 0.5 seconds for this one, 0.5 seconds for this one. We'll do the same thing down here. And now when we run this world, it's a lot faster, but you see that it actually aligns the animation. There is another place where we can change the pose duration if you go into the pose, but we will visit that one at a later time. All right. Well, if everybody followed along that one or enough that they can go off and attempt this tutorial on their own at a later date, you can always circle back and watch this, obviously, and figure that one out. Then I'm going to go ahead and move on to our next lesson. All right. So reminding that when we go back to the lessons, for the control structures, the overview might be enough, and if you could follow along those different types, or maybe you've been exposed to an if-else and things like that on your own in the past or through some other programming environment, then that gives you the basics of how to do them in Alice. If you want a little bit more in either just how to do them in Alice or what they are, we have these longer lessons. We definitely have enough time to jump into the next one here. Loops is a great thing to use in Alice because a lot of animations you're going to want to do, such as this sort of picture here that is the main image for this one, of having things swim. Again, we just looked at the bird that has the pose for opening and closing wings. That's something that you'll probably want to loop a bunch of times when we start doing talking animations and you have the mouth opening and closing. Another great example of animation things that benefit from using programming concepts like loop. So we're going to jump into the longer lesson on loops. So here is our presentation Google Slides for this one. And we call this one control structures repetition in here, just another way of talking about it. And I will jump into the presentation. So it will be a little bit redundant to what I talked about before, but I want to go a little deeper into them. So repeating execution, computers don't get bored. So again, great example is the shark one over here, where we see the get tail left, right, left. And then while the shark is swimming, we can also do that. So it's a continuous loop. So there's both the count or the while version of the same one. It's going back to the example in the previous lesson of the jumping jacks while working out. This would be, as long as I have the shark swimming, it will continue to move its tail. The repetition control block, when we go to build these, and we're going to do a tutorial quickly to have you implement all of these, similar to our other basic code statements and procedures, has required parameters. So in the count loop, it will be the numbers. So when that pops up, you'll have the option to do 1, 2, or 3, or of course, custom whole numbers that allows you to add any number that you would want into there. In the while control loop, it defaults to a while this condition is true, it will continue to work. And again, because we don't want to allow you to create broken code, we will force you to either make it true by default, in which case it will always happen, or false, in which case it won't happen. But we'll come back to this later. You will obviously then go and change that to something. When we talked about the design lesson, we talked a lot about whether you can storyboard, to sort of write that storyboard up as an algorithm or potentially as a flowchart. These loop ones are much easier to sort of show in a flowchart. It's not to say that you can't do a text-based algorithm when you're writing it up to pre-plan your program, but here's an example of what a count loop would look like as a flowchart. And essentially it breaks down to, we want to count up to 10 is the loop. So did I reach 10? When it first hits it, obviously the answer is no. We will do something and we will add a number to that and come back to this conditional diamond. So then we would be at, it has happened one time, so it hasn't reached 10. And we're going to go back around, back around, back around until it is finally a yes, in which case we will move on with other code. So back to our previous example is the do the jumping jack 10 times. Each time it goes through, we'll keep track of how many times it has done the jumping jack, and when it has actually gotten to 10, it will stop doing it. A for each in loop. So we talked about this one of doing the wave. The way that this one looks, if you were to flow chart it, would be to say that it grabs an item from that group of items, that array of items. It is going to check, is this the last one? Or did I just do the last one? And if we did, it will, come here, boo. Do something using the current array item. It will then grab the next item and it says, is this the last one? Or did I grab the last one? In which case it will then circle through again. So again, the way that you can continue to go through it for each of the items in the array. So again, going back to our wave example, this is our array of characters. So they're all bipeds. We will do the biped character array, character wave, and it will just continue on one through this one, once through this one, once through this one, once through this one, and then we'll realize that I've done them for all of them and we'll move on. The last one is conditional loop execution. And so this would look like if you flowcharted it. And so in this case, it would be, is the condition true? Then I'm going to keep doing something. And it will just keep in this loop going up this arrow, checking is still true until something about this changes and it is not meeting the condition of being true, in which case it will know and it will move on through the rest of your program. So this is something to be aware of. Sometimes you want it to be an infinite loop that can't be escaped, but a lot of times you will want it to change when something changes. So in this case, going back to our jumping jack example, sometimes you'll want something to happen while a condition is true in the world. It is true or false. Then we add this conditional of saying that when I look away, it will stop doing it. So this is a conditional version of a while loop. So building a count loop, again, we can do a custom whole number. You drag it in, custom whole number, add the number of times you want it to repeat, add whatever code you want into the block. So we talked about anytime you see this, but even once there is code in there, you can continue to add more content. When it is empty, it will just remind you of where you can add code. You can nest them as much as you want. So in this case, there's the count loop, there's the do together loop, and then there's the do in order loop nested inside of it. To build a for each in loop, when you drag the for each in loop into my first method or wherever you're building your code, you'll see this one pop up. The required items are going to be first the item type. So again, we have a small lesson on data types, but really just think about, of the things that you're going to put in there and want to execute this code, how would you describe them at sort of the highest level? So are they all going to be bipeds? If they're going to be different types of characters, then you might want to set them as models. When you're choosing that, you'll be able to see some other things. You will want to name it. So in that case, what it was going to be. So in those would be like each biped or each person doing the wave or something like that. And then we will get to the array. So you drag it in, that will pop up. It becomes, if you have covered or want to think about this in terms of the functionality in programming, you're sort of setting up a local variable that name is going to be it. So in this case, the type is fish. The item name will be that each type was a fry. That's what you will then drag into the procedure that is inside it, or the statement. So you see the for each fish fry in the fish array. So we had built a fish array elsewhere. You will drag this fry statement. So you can either do it by replacing the object in the statement itself, or once you have created that array and then that variable, it will be available from the drop-down object menu as well. We'll get into showing a little bit of that in the tutorial. For building a while loop, you will drag it in and it will require you to set a true or false condition. If you've already created a variable, it will show up in this list. Otherwise, set a true or false and you can replace that later. So again, the default, while true is true, will continue indefinitely. If it is false, it will never fire and you would just continue on with your code. So obviously we don't want things to just always happen or never happen. So one of the ways that you add functionality to a while loop is to use functions. So we haven't done, if we have enough time today, I might do a quick run through our small lesson on using functions. You might want to circle back onto that. But if you remember from our intro to programming in Alice, the purple is statements and tells something to do something. The green is functions, which asks the computer to return some piece of data. So things like distances from, or if it is above or below. These things can end up being true or false. So if something like a is behind will either be true or false, but could change if we change things in the world. So then this would happen as long as this condition is true. Relational expressions, again, we have a small rundown of that. Relational expressions are, the greater than equals to or equal to. So you'll see the basic rundown of the drop downs over here. We can do relationals between numbers, between objects, between directions. You'll see the ones that we have built into Alice here. These are another great way to create something where a relationship expression will give you a way to make it not true when things either in variables, in the world, relationship between objects and things like that become true or not true. This will turn on or turn off. Again, extending that, there's the ability to add a variable to a loop. So the relational expressions where if I'm replacing this true, you see all of these options. You see the relational ones that are built in. The other option is to actually have a variable. So as long as the variable is a true-false variable, that can replace it there. So in this example, we had a seen as active variable that is a Boolean. So again, data types lessons if some of this is not making sense to you. But the very short of it is a Boolean is just, it means that it is either true or false. And so we created one called seen active and we set it to true. This variable is something that we could change somehow through code, either through an event or some other mechanism to make it true or false. Again, once you've created any of these loops, you can add statements into it that will then run when that loop is running. Nested blocks, you can actually do a while loop within a while loop. So again, all of these things allow you to create whatever levels of nesting you need to get the functionality that you want. Just a couple of tips and tricks. This one happens a lot in a lot of Alice worlds. When we do looping animations, so whether it's a move forward or a turn or something like that, the default in Alice, so that things wouldn't seem so abrupt, is that we do this smoothing in the animation. So if something is moving forward, even if it's for 1 second, it moves forward for 1 second. It is not a constant movement velocity. We sort of speed it up and then we slow it down. Again, when we get into the tutorial example, you'll see what this means. But it means that if you put multiple of them together, it'll sort of start to feel jarring, where it'll speed up, slow down, speed up, slow down. And instead of being a smooth movement forward, it will feel stuttered. This is the animation style. So it is by default, begin gently and end gently, this bottom one. If we want it to be a continuous acceleration or continuous velocity, we will sub in begin and end abruptly. So in our example, you'll see how that plays out. Again, same as the other ones, you can dissolve a count loop. So if you really liked the code that was in there, but you didn't want to delete the whole loop or something like that, you can just dissolve it. Coming down here, we're going to do the exercise and project associated with the tutorial control structures loops. So if you come to here, again, if you are following along at home, we have a Teacup starter world. You're going to want to download that. And then if you want to follow along the directions, this is the one that we're going to do. So the basic setup is, if you see the picture, this is the world you open it up. If any of you have been to a theme park or a carnival or something like that, there's a lot of these rides where, you know, it is intended to make you feel G's and potentially throw up, especially depending on how much you've eaten. This big disc will spin, the little discs will spin, and then the teacups inside of it will spin. So the hare is our one rider on this ride. And so what we're trying to do is think about creating a carnival ride where we have these multiple levels of spinning. It's a good way for us to show how you could set up a cool animation using loops, and then also there's just different variations of it. So that's our theory, the spinning teacup ride. Setting up the scene, again, don't bother setting this one up yourself, just use our starter world. So in this case, I will come back to here. I will browse to my desktop where I have this Teacup starter. And here it is. So in the setup scene, we've got all of this. Something we talked a little bit in the past, and there is a how-to on it, is the idea of vehicling. So this is something that is done in Alice for grouping. And so the idea being that if this big disk is going to spin, anything that is vehicled to it, so essentially think about the word meaning that says the disk is the car and anybody that is in the car will go with it, means that see this property over here. So we have the properties panel in the scene editor. If I select this T-tray disk number 3, you'll see that the vehicle of it is the disk, which just means that if that disk were to move, all of these are going to move with it. We've done a nested version of this where then if I look at the teacup is actually a vehicle to the tray. So if the big tray moves, the little tray moves, then the teacup moves. So if I just do a basic drag, you'll see that they are sort of all grouped together. Not going too deep into it, it is a one-way with vehicling. So if I move this teacup, you'll see that it doesn't drag. So it's not really the same as grouping them. It is very much in the concept of one listens to the other. And so as those things move through, the directions for one will go down to items that have been vehicled to it. But if something is at the bottom and is not vehicled to something, or they are not vehicled to it, it won't impact them. So we've set that up for you. Something to think about in other programming. We'll talk about it again when we get into events for setting up first person versus third person cameras and things like that, is that vehicling object of having the camera ride along on things, etc. All right, so that scene has been built for you. We are back in the code editor, so that gets us through. So planning our program. Let's think about how we want to build this. And so I wrote a short script that is, the teacup ride has a large platform that spins clockwise 3 times for each ticketed ride. So the concept is I get on this teacup ride and I'm going to go around 3 revolutions of that very big disc. Each time that big disc goes along, the 3 smaller platforms, or the teacup or the tea trays, each spin one after another, one turn clockwise. Sometimes if you see this, everything is spinning all at once. Other times on like the whip it and stuff like that, one will whip and then the next will whip. So that's kind of what we're doing, so that there is a point where the smaller tray is not spinning, it gives you a little breath, and then it spins to accelerate you some more so you feel that. Then you get a little break while the other ones spin. If you're following my teacup ride idea. And then the last one is each of those little teacups is just going to spin all the time. So while the ride is running, all 12 teacups are going to spin clockwise. And so one is going clockwise, the other is going counterclockwise. maximum excitement, and vertigo. All right, so if we were going to flow chart that out based on what we learned in the one lesson, the first one is, first we're going to do this for the large platform spinning 3 times. So you see the ride starts, has the platform spun 3 times, no, keep going around, and then once we have fulfilled that and we have gone around 3 times, then this answer to this question would be yes, and you come over here and the ride is over. So that is the basic idea of like how we would do this if we're flow charting it and trying to think about, what is the functionality underneath it. So next, let's break down the next component, which was each time the large platform spins, 3 smaller platforms each spin one after another, 1 turn counterclockwise. And so I've sort of, in all of these, bolded the why is a conditional. So if we see things like if or each time or stuff like that and have conditional statements, that should be something that tells us that we are probably going to use a conditional code block. Again, the large platform is the object, the verb is the spin, so this is what we'll end up programming. Since we want these to happen at the same time as the big one, in our little flowchart, we talked about how you can use a line for a do together. So anything inside of this will happen at the same time. So thinking about it, the ride starts. The whole ride is 3 times around of the big platform. But inside that, we have the large platform spinning. And while that large platform is spinning, we have this other thing going on. So this is the do together. You select each of the smaller disks. It spins once. Have we done all of them? No. We're going to go back around. And so this doesn't move on to the next one until it has done both the large platform spin and each of the spins of the smaller one. Let's add in the last part of our story that says while the ride is spinning, the 12 teacups will continue to spin. To do this, we're going to create a variable that tracks when the ride is running. For some of this tutorial is meant for all of the depths of variations. If all of this is too complicated for you, you can just think about it in terms of a count loop, and we'll show you an algorithm of how to do that one. So if this is overwhelming now, don't stress out about it. Finally, we continue. So create a variable for when the ride is running so that we can turn that off and the 12 teacups will spin clockwise the whole time. If we add that to our diagram, the ride starts. We set this data point of is the ride running to true. So then we come into here and you see yet another do together where the same thing that we built before, it's going to spin 3 times. All of this is going to be conditioned. When that is done, we are going to say that the ride is over. And so we're going to set this variable to false. Over here, we have our new element of this flow chart that says when the ride is running, it's going to keep doing this loop. In terms of that, we have the spinning teacups. And then once we set this to false, it will stop and these will stop spinning. Take some time, look at this, think about the logical flow of it. Again, one of the things that's the beauty of this is pretty straightforward in having the disk spinning. It could just be a turn a multiple of times, but this example is really just a simple version. You could have lots of things happening that are going to keep happening. So there could be environmental props that keep going while the ride is running, things going up and down as well. So it could be spinning and going up and down. You can play around with that later. So let's jump in and actually start to build this. So the first one that we're going to build is the large platform that spins clockwise 3 times for the ticketed ride. So I'm going to come over here. So the first one we're going to do is a count loop. So here is the count loop. If we drag that in, remember that it then has you choose the number. We talked about it being a 3. So now we have the count loop that's going to do something 3 times. I believe we have this first one going clockwise, so that is a right turn. If I come and do from the object drop down, the bigger disk, we'll go with the disk turn, right or clockwise. 1 because we want it to be a full revolution. So now we have this code, count up 3. So it's going to do this until it gets up to 3. If I press run world, you'll see spun 3 times. So our ride is there. It might be fun. Could be funner, I think. So step 1, everybody successfully follow me thus far and create a simple count loop. I'm going to run this one more time. And you see how it's going around once, and then there's a slight pause, and then it's going around again. This is the begin and end gently. So you can actually count them because you can see them. We want ours to be far smoother than that. So we're going to come in here and change the animation style to begin and end abruptly. Remember what we just watched a second ago. Now when I run this world, you see how it is. There's a slight hiccup when our program is just slowing down, but it is far smoother of a continuous turn. All right, moving on to step 2. Well, I guess before I move on to step 2, here's an algorithm if you just want to focus on the count loops, where we do a do together, the disk turns. So that's what we did right now is the 3 count loop. You could also, just using do in orders and do togethers, write this. So another do in order would be for each T tray to turn in a count loop of 3 for all of the different teacups that we have in there. So if you're not following the arrays and the other things and you're not doing the variables, challenge yourself to just build it using this algorithm right here. We're going to continue on and show the examples of all the different types of loops that we have in Alice. So here is the for each in control loop. So this one we're thinking about that time where we said each time the large platform spins, we want the 3 smaller platforms to spin. So we are going to do, the first part of that was that we wanted to happen at the same time. So you remember we diagrammed out the do together. So we're going to say while this one, well, I guess I shouldn't use while since that's the while loop. At the same time that this spins 3 times, we want this other thing to happen. And we want this to happen where it's the first one spins, the second one spins, and the third one spins, which is a great opportunity for us to use the for each in. So I'm going to drag that into our do together block. So when we use a for each in, just remembering, you'll have these 3 things that you need to set. And so for this one, we are using the T trays. You'll see that we could use numbers, whole numbers, all these other things. There's also the one that says gallery class. If I come into here, you see the inheritance. If I set it as a thing, it could be any of these types of objects. We could use that, but I'm going to come all the way down here and say that we're going to be a little more specific just for us to be able to track it. It's going to be just the T trays that we're using. You'll see on the left side, it's showing if I set this type as T tray, these are the only ones that we'll be able to add to that. So now it's T tray. We're going to call this each T tray. And then we're going to set the array. So of the things that we want to process through this, we have to add them to this array, or not really list. So I'm going to add the first T tray, the second T tray, and the third T tray. So now we've created this. You'll see that we've added all the ones that we're going to want the code to execute. Add this one in there. It is now set up here if I need to go back and edit it. When I hit OK, it drops in the for each in block. So we see T tray as the type, and then the variable that we created, which is for each T tray, and then the array that it's going to pull from. So you'll see that we have all of them represented. I am going to go to the first T tray just to make this easy on myself. So here's this T tray turn. So the first one turned right. These are going to turn left. I'm going to drag turn left. We'll go 1 full rotation. And so this would actually have it only spin when it came into this code, just run for the one that we set in there. The beauty of this variable that's been created is it's going to replace for each of these items in the array. So I'm going to drag that to replace it. And now we see each T tray will turn. We also have the option that I could have done that from the beginning, not dragging it from here in our little presentation, where I could have come to this one where it's each T tray and we'll already set it up for that. It will show me what is possible. So instead of doing it the way that I did it, where I grabbed one of our representative T trays, I could have taken the drop down to select this representation and drag the each T tray turn left 1. All right, I'm going to run this to see what happened when we wrote that code. So here we are again, run. You'll see that they are spinning. Oh. We're going to restart that one. It is almost happening too fast. In that case, it wasn't. So this took 1 second and did it 3 times. This went through, and each one took 1 second, and so it went through it once. I made the mistake of saying that what we wanted this do together to be in, pardon me, is around this disc turning. So let me restructure this as you watch. Now I'm going to run it. And you'll see that the challenge is that they don't align, because each of those T trays turning left 1 takes 1 second, and the large disc spinning takes 1 second. So we have a time alignment mismatch that we talked about when we start nesting things. So our options is to make this into 1/3 of a second, if this is going to be 1 second, or set this one to 3 seconds. So custom 3 seconds. All right, I apologize for the mix-up walking through the tutorial, but so yes, we want the whole ride to do 3 loops. We want this large disc to spin once, 3 times, and then we want each time that first one spins for each of the smaller T trays. Now if I run this, you'll see we get that sort of whip-it action where it is going through each one after another, so you get a little breather before it's your turn for your T tray to spin. Well, so here we go with the for each in loop. And we will now stop this one, go back to the tutorial. The next thing we want to add is the while loop. So while that's going on, we want all of the 12 little teacups to spin for as long as the ride will run. So first we are going to drag in the do together block in your program to the existing do together block inside of it. So, or add the other one to it. Essentially, we're saying that we want our next while loop to happen at the same time that this is happening. Let me double check that I'm doing this. Yep. And so at the same time that our bigger loop is happening, we want to set a while loop. We will default it to true, and we will use a each in together. So remembering that this one is the wave, the bigger do together block that we talked about in the first control structures overview is this each in together. Again, we're going to set up an array of gallery class. We're this time going to do it at the Teacup level. Something has gone and added multiple variations of Teacup. So I'm going to step back up to the prop level to make sure that I can add all the ones that I want to. So we'll call this then each Teacup, create a custom array, and then we're going to grab all the different teacups that we have in here. So there's the Teacup playing card, March Hare, Cheshire. There's the first 4 of them. Then there's the second 4 of them. And finally, the last set. So we now have all 12, each teacup. And again, now we have the option to get it from each teacup, or we can do it from dragging one over. So in this case, we're going to have each teacup turn. We've gone right, left, right, 1. And so now we've created while this is true, at the same time that our bigger loop is going, we've got the true is true, this list of all the teacups. We want them to happen at the same time, so we're using an each in together block. Each teacup, again, you could have added just a turn for all 12 of these, it would just taken a lot longer to build and a little harder to edit. But now if I run my program, you'll see that it's kind of hard to mentally grab, but you'll see the teacups are spinning at the same time this whole thing is going. The challenge being is that since we did while true is true, they just keep going forever. We created an indefinite loop. We want them to stop when the ride is over. So the next step of what we're going to create is a variable that will replace this true that we can turn on and off. One other quick addition I'm going to do is you saw that when they were running at the end, they were doing that same thing as the big disk where there was a little hiccup at the beginning of the end. So I'm going to add animation style, begin and end abruptly. Begin and end abruptly, which will smooth that out. All right, so variables, and we haven't taught this one, so just follow along. But a variable is something that you can change as the program is going. So you can do them locally, you can do them in a number of places. We're going to say that in our example, we wanted to turn the ride on right when our program started. So the value type is a Boolean, which is the true false. So you see example true false. We're going to say that this one is called ride is running. So if the ride is running and when we set it, we want to turn it to true. So when we start our program, the ride will start running and we will turn it off at another point. So now you see you've got ride is running as true. We've turned our ride on. At this point, this while loop isn't referencing it, but there's two ways that I can grab this variable and set it in there. So one is to just take it from where I've assigned it. If we had done that somewhere else, because when we teach variables, there's a number of different places you could put that. The other option is to replace the true. You see all the things we talked about before, where I can use a relational expression, or I can use an array that we've got going. And then we also have the ride is running. So we're going to do ride is running. So ride is running is true, while ride is running is true. This one will essentially create the same exact thing that we had before, where I run it. Even though we've added the variable and we've replaced it, we have not ever turned the ride off. So big disk, little disks, tiny cups, we get to the end, there they go. The bunny will be sick because they are on a forever spinning ride. So we need to figure out where to put this so that we can turn it off. If we went back to the diagram, really the place that we're going to set it is at the end of, going back to our pre-planning, at the end of the platform spinning 3 times. So when we escape this loop, we want to set this to false, which will then turn them off. If I come back to Alice, the way that we do that and change it is you have the variable where we create the variable and we have the assign where we change the value of it. I'm going to drag this to the bottom first just to show you how you set it up. The ride is running. We want to set it to false. So this now will turn off our ride. We have our count loop here and we have our while loop here. If I drag the ride is running into this one, it is still inside this do together. So the challenge there is that it will happen at the same time as this. So let me run this program and show you. They have already stopped spinning. And the reason they stopped spinning is because as soon as that first loop happens in the do together, we essentially set it up to stop. We can put it here. Again, same thing, do together. It has already stopped because as soon as it executed. What we want to do is we want it to do this 3 loops and then execute this. So we are going to force a do in order, drag our count loop in. So it'll continue to do that at the same time this other one. But as soon as we finish this count loop, we will turn the ride off. Now, if I run this world, we should see it execute 3 times. Everybody's spinning. And as soon as the ride stopped, the little teacup stopped. So talking through that one again, when we diagrammed it out, we wanted our full ride of the large disc spinning to the right 3 times, and we wanted each of the little trays to spin through. We want that to happen 3 times, and that's when our ride ends. And so that's where we're assigning the variable for ride is running to false, so that when this is done, and it essentially will stay executing this code, it will pop out, it will turn it off, In the do together, we had this while the ride is running true, which was just going around and around and around while this one was going around. As soon as this one pops, sets this to false. This one reads as while ride is running is true. It will keep doing this, but as soon as it is false, it will get to the end of that and it will stop executing. That is sort of a description of the code that we're seeing here and how you're executing it. The last little part says that once you've built this program, the beauty of the while the ride is running and some of these other ones matching is I can now change this to as many times as I want. So maybe I want the ride to be shorter. If I set this to 1, everything will stop after it goes through that one time. So because these are in that loop and because this loop calls out the end of the ride, it stops this one. I can just completely alter how many times all of these execute just by changing the number in the count loop. I can also then modify some of the durations. If I wanted to change this duration to 0.125, now if I run it, you'll see that they are spinning a little bit slower. If I want to make it even scarier, I can change that one. And now you can see they're blinding speeds of the teacups. There's different ways because we have not done 12 versions of this I'm going to use the for each that we can modify it quicker. So it just shows you how using some of these control structures makes modifying your program later, editing your program, it just makes it for a tighter program instead of being the longer form. Well, then I think with that, I'm going to wrap this lesson. We covered a bunch. Again, all those materials are online. This was the basics of the control structure. So all the different types of control structures, a quick tutorial on just how to manipulate and nest and unnest, do togethers and do in orders so that you get the behavior that you want. And then we went over all the different types of loops that we have in Alice or repeating behavior. Again, we went into looking at variables and other things like that. So if you haven't covered variables or know what a variable is, you can just use the count loop. And a lot of those things you could do just by nesting do in orders and do togethers of a count loop. You can also then, if you wanted to, go and look at the smaller lessons on data types or variables, in which case you should be able to learn a little bit more there. Or if you're a teacher and you're teaching this, those could be interjected to any of these lessons to make each one a little bit longer, a little bit shorter. But yeah, so if nobody has any questions, then that is the lesson for the day. And I will dump out. I'm going to jump into the other meeting just in case somebody wants to do a QA. Thank you again for joining us. Look for this video to show up on YouTube. If you're watching it on YouTube, the previous lessons should also be there, and the later lessons will also be coming soon. So check alice.org and join us in the future.